Okay, so now we're going to dive into what's called the API wrapper. And this is a part of the RTEM library that kind of shields us from the process of making a request sort of call for the using the header and all the different details that we had to go through before. It kind of packages that and shields you from that. I wanted to show you all of those details because then you get a sense of how an API works in a little bit more of a fundamental level. In case you ever want to do an API on another type of service where you don't have this API wrapper. But this API wrapper, it's going to shield you from some of that complexity, make your life a little easier, do more with less code. So if you do use the API calls in your own notebook, you might want to start at this point, basically at the wrapper level. So what happens at the wrapper level is that instead of doing all the things that we had to go through with the requests library, we simply use the client object that we created very early on, which was a way for us to authenticate. It basically helped us, I think we put in the API key up there to authenticate our connection to the backend API. And in this time, we're going to, instead of doing all that work, we're going to use the function get_all_buildings, which is encapsulated all those little details we just saw before. And here we get that same output we were looking for. It's kind of the first building inside the API, which is called building 441. Here's all the details that we just saw before. Once again, if we put that into a data frame, what we can do is look at that sort of two-dimensional representation of these 229 buildings. We can see a lot of the columns here, and we see some of the data and some of the examples of the data. And we can dive into this. And in fact, you could, if at this point, if you want to pop over to Excel, you could do that, and you could export this as a CSV or as an Excel file using pandas and play around with it there. That's fine. A lot of people like to do that. I like to keep in pandas because there's other tools like .info that we can use to, in this case, look at all the different columns. So this is the information that we have for each of these buildings. We can see here that, they're in the columns, what's in the columns. So there's 229 non-null values, so actual values of integers for the ID of the building. The organization ID is also an integer, so it's coded basically. The name is, if we go back up here, we can see an example. The name of the building is also coded as something that's representative. You can see the square foot of the building, so the floor area, image, BMS manufacturer, product name, BMS version. These are all not data that's available. Time zone, info status, equipment count, and point count. These are all things that are available. So for these 229 buildings, you can dive into things a little bit more deeply, which I'll show here in a second, how you dive into the details of the equipment and points from each of these buildings. So let's take our building that we started with up here, which is building 441. We know that there's 20 pieces of equipment and 1,293 points. So let's see if we can see what's, what those equipment are and whether we can extract the time series data from those points. So first thing we'll do is we will use now we'll create a variable called all_equipment, and we're going to use a function called get building equipment, and we're going to put 441 as that's the ID of the building we want to look at. That's the attribute that's going in and grabbing the equipment. So here you can see when we have that data frame, we look at the first 5 rows of that data frame, and we can see the ID, building ID, etc. So this is a spreadsheet that shows the basics of the first 5 pieces of equipment of this building, which in this case are 5 boilers. We can also use .info to kind of understand what's inside this data frame. So we have, in this case, equipment type, ID, abbreviation, tag, flow order is here, parent equipment, child equipment. So the hierarchy of the systems, points, and then tags. And if we look back at the representation up here, we can kind of see that there are these different metadata about these pieces of equipment. We can explore and understand what they mean. Tags, these are tags that are allow you to sort and filter, which we'll show in future videos. And then points, there's a column called points, which really has embedded in it a data structure which has the different points that are available for this piece of equipment, for each of these pieces of equipment. We can also use a function from the API library, wrapper library called point selector. So point selector allows us to create an object. In this case, we'll call this object query. So we want to use it to query. We want to use the functions. We're basically creating this object, which is a class, which is a point selector class, using point types as a function. So we're going to set the point types that we want as zone temperature. We want the equipment types as fan coil units, and we want to get that from the buildings, 3 of the buildings, 417, 162, and 259. So when we do that, and we basically use that query point selector object, we go back to client, we use the function .select points. That basically takes our query and finds all the points within the API that meet our criteria of zone temperature, fan coil unit, and from these 3 buildings. And when we look at this, we see a bunch of numbers, right? And these numbers are the unique identifiers of those points. So these are the unique identifiers we're going to use in the API to collect and pull data, time series data from the database to extract data. So here you can see we created a new list called points, which is we're basically pulling out the list out of these selections that we queried. And what are we going to use this list for? We're going to come on down here, and we're going to use this list to get data, get points by IDs. This is going to get the metadata of these individual points. And it looks like we've got 100 points. There's 109 points in the back end, which are the fan coil unit, zone temperature sensors from 3 buildings out of 229 buildings, right? So we're just really kind of grabbing a little subset of data out of the API. And here you can see the different metadata that you can get from each point: building ID, last updated, first updated, which you'd think would be a date time object, but it looks a bit weird, right? You've got the descriptions, you've got all the different information about the point itself, and you even have a description of where it's coming from and things like that. So last updated and first updated, this gives us an indication of when this time series started and stopped. When was the oldest and the newest data points that we can extract from this. But you'll notice that the object here, 1.53557, that doesn't seem like any date time I've ever known. Well, turns out it's actually what's called a Unix timestamp. And here you can follow a link to find out what that means. So we need to convert that Unix timestamp into maybe something that it's more human readable. And we can do that using the date time library. If we do that, we can see that if you take, or basically from the date time library, we're going to set the starting point of date time to be UTC, which is a step that we need to do in this case. And then what we can do is use within Pandas the .apply function to apply a function to convert those objects into something that's more human readable, which you can see here is 2018, September the 1st at 3:45 in the morning. So we want to use this function to get our first and last updated columns transformed, which we've done. And here you can see for one of the points that February the 1st of 2018 is the oldest timestamp of this data set, and July 8th of 2021 is the newest timestamp out of all of these points. So this is helpful for us to be able to select data, to basically pull data from the database and the data set. So we want to, let's create a way to query the time series according to a date range. We do that by creating a start and end dates that we want to pull the data from. So we want to pull data from 2018, January 20th until February 20th of 2018. So 1 month worth of data. And to do that, we can use the time series query function from the library. We can execute that query. And what we end up with finally is time series data, sensor data. This is what we want. This is the crux of the whole competition, is to take time series data and transform it and analyze it and things like that. So we've basically been able now to get 27, 5 rows. Well, this is the dot head, so this is just the top of this data set. We're getting the first 5 rows, 27 columns, so we're getting 27 different points. You have the point IDs there. At this point, once again, you can export it as a CSV if you want to play around with it in Excel. I mean, that's comfortable for some people that are not so familiar, let's say, with Python and Pandas. They can go between Excel and Python, let's say. But you can now, once you have it in this data frame, you can quickly plot it, which we want to do here. And we're going to use the Seaborn library to do that. And so finally, what we have now is beautiful time series data. It's not so beautiful. We could do better because it's a little bit jumbled, lots of noise in there, but you can see that we've extracted about 29 different points. These are, I think, remember, zone temperature sensors from fan coil units across the 3 different buildings. And here you can see a bit of data from those points. So this is really showing you that we've extracted data from the API. So in these videos so far, this is enough to get you started. This is enough to get you going because now you know how to query the API for buildings, for equipment from those buildings, and also get a bit of time series from those points. So stay tuned for upcoming videos where we're going to dive into this much deeper. We're going to look at some exploratory data analysis and from the metadata side and from the time series side, and really look at what do we use this data for. So look forward to seeing you in the next set of videos.